Good morning and welcome to our Math 8 lesson. This is week 4 and we're going to be talking about volume. Last week, if you tuned in, we also talked about volume. We talked about the volume of a cylinder. We talked about the volume of a cone. And we gave you a challenge to find a sphere around your house. So hopefully you did that. I brought a sphere with me today. I'm sure you know what this is. Maybe you've played outside during this quarantine time. A volleyball. So we're going to look at how to find the volume of a sphere. In this lesson, we're going to see how to find the volume of this volleyball. So are y'all excited and ready? All right, let's go. This is Essential Concept 2, solving real-world and mathematical problems involving the volume of a cylinder, a cone, and a sphere. Just to recap, if you didn't join in last week, which you can always go to YouTube, MCPSS TV, to find that lesson. But just to recap, this is the volume of a cylinder. A cylinder has radius and height, and so the volume of a cylinder is pi, which we approximated last week to 3.14, times the radius squared times the height. Okay? Remember, a cylinder is like a Coke or like a canned good, maybe green beans or corn. And then the volume of a cone. The volume of the cone is 1/3 pi times radius squared times height. And we did a water experiment, if you tuned in last week, and we said that 3 of these, as long as it's at the same height and the same radius, 3 cones would fill up this cylinder. So that means that this is 1/3 the volume of a cylinder. Today we're going to do another water experiment so we can see how a sphere and a cone go together. Okay, so here we go. What is a sphere? Hopefully you found one around your house. Maybe you have one handy with you right now. But an example would be a globe, a basketball, volleyball. Maybe you have a fishing bobber. Earlier, Miss Murrah had on some earrings that were spheres. They had little tiny spheres on them. This necklace, maybe you've gone down to Mardi Gras and you've gotten some beads from Mardi Gras. Necklaces oftentimes have little spheres on them. What is the volume of a sphere? We need to know that in order to calculate it. So the volume of a sphere can be calculated by using pi, which we're going to say is 3.14, we're approximating it, times the radius cubed. Now that's different from last week because last week our radius was squared, but this time cubed means we have to do it 3 times. We're also going to multiply it by our fraction 4/3. Don't let a fraction scare you because all that a fraction means when we break it down means that we're going to multiply by 4 and we're going to divide by 3. And then volume of a sphere is always measured in cubic units. There's not an actual height of this sphere because it's circular. And so we're going to prove how we can find. Now there is a diameter. Diameter is all the way from the center all the way across, through the center, through the top to the bottom. And there's a radius. We're going to talk about how we can figure out the height. So just a recap, volume is V, R stands for radius. If you see that in your formula, it's normally a lowercase r, and then we have radius times radius times radius is radius cubed. And then, of course, approximation of pi, 3.14, and then our 4/3. So this is an example of your volume of a sphere. All right, so here is our water experiment. I'm going to explain what's on the screen first, and then we're going to go to the water and prove what we're saying, okay? Just like I told you a while ago, there isn't a height for a sphere. However, though, if you look at that first box, it says that 2 cones, the volume of 2 cones is equal to the volume of a sphere. Now, we need to reference the same height. They do have to be the same height. Then remember last week I told you that you could put them side by side and make sure that they had the same height. Okay, and these do. Okay, same height there. I know it may be a little hard for you to see at home, but they are of the same height. And so we can say that 2 of these cones filled up will equal this sphere filled up. Okay, So radius and radius would be our height. So I'm going to go to the board real quick just to show you that. So if I have a sphere and I have a cone here, okay, do my best to draw a little cone here. Okay, this radius halfway here, okay, and this radius, okay, well, let me do it this way. That way, let me draw it down. I should probably use an eraser, not my finger. This radius, and you can go from the top or you can go from the side for the radius. And if I go all the way, if I do the height here, which we normally call h, we normally call it the height, but this time we're going to call it radius, radius. Radius plus radius. So here, if I say that, then I can say that the height is the radius plus the radius. Well, when I do this, I have pi r squared times the height over 3 plus pi r squared times the height over 3. What I'm actually doing is I'm taking away the height and renaming it r plus r. Okay? All right, and that is shows in the example there, r plus r. Well, r plus r, if we were simplifying that, that would be 2r. Just like if you had 2 candy bars. A candy bar plus a candy bar would be 2 candy bars. So r plus r is 2r. Okay? Well, when I do that, I can pull these 2's out. If you look at what we had on our screen there, we can pull the 2's out from the r. So pull our coefficient out front here. Over 3 plus 2, pull out our coefficient, r over 3. Okay, I'm going to put these down just for a second so I can show you. All right, so now I have my 2 out front here, still have my r. What is happening right here? R squared and r. R squared and r are being multiplied. That's where my r cubed comes from. So I'm going to come up here so I have a little more room, and I'm going to rewrite that as 2 pi r cubed over 3 because I'm just combining these like terms. R squared and r, if I multiply those, r squared times r is r cubed. Okay, plus, I'm going to do it the same happens over here. 2 pi r cubed over 3. And now you see 2 fractions, okay? They look maybe a little different than the fractions that you're used to seeing, but they have the same denominator, and we're adding them. So what can we do with our coefficients here, our 2 and our 2? We can combine that to equal 4. 4 pi radius cubed over 3, which is the volume of a sphere. Yes, volume of a sphere. I want to make sure I said it right. I was thinking cone and said sphere, so that's awesome. So, y'all want to prove it with water? Let's do it. All right. So we're going to pour in, and I have a funnel here. Maybe you've seen this before. You've worked maybe with your dad or mom in their shop. They've poured oil in the car. So I'm going to put this in. There's a tiny little hole in my sphere. I'm going to put it in there so that we don't make a mess with the water. And just to hold it, I'm going to put it in this there for just a minute so that I can fill these up. We got to fill 2 of them up. We're going to prove it. Are you ready? Fill it all the way to the rim. If you watched last week, I did a pretty good job of not spilling it. We're going to try to keep that same. See if we can. Steady hands. Oh, spilled a little bit out. See it? Okay. Ooh, it's getting there. I'm going to pull it back up so you can see if that's about halfway full. Oh, look at there. It's pretty close. I spilled it a little bit, but you're still going to be able to understand what we're doing here. So, fill this one back up. Almost to the rim. Needs a little bit more. If it's a little off, I think you guys will get the idea, though. Let's see if we can be a little more careful there. Okay. It's got a little bubbling sound to it. And, oh, it's coming out a little bit. Okay, it's coming out a little bit just because I had the funnel in there, okay? And look at there. There is a little extra water left over, but you can see that 2 of these fills up. I think a little bit poured out because I had the funnel in there. But 2 cones of the same height fills up your sphere. So the volume of 2 cones of the same height, same radius would be the volume of a sphere. So that is fun. All right, I'm going to stick my sphere back in there, move that out of the way. Okay, clean up a little bit. And now we're going to find the volume of this volleyball. I'm going to take it off there for just a second because I don't want you to see the answer, but I'm going to talk to you about this. Let me erase my board for just a minute. And we're going to find the volume of this sphere, okay? I can't really measure the height of this sphere or the radius of the sphere because it's not in half, like I could with this one. This is called a hemisphere. It's half of a sphere. See, I could put a ruler on here and measure from one edge to one edge, but I can't stick this ruler inside of this ball, and I can't really tell exactly where the edge is. So what I'm going to do is I'm going to use my fitting tape here, measuring tape that you might see if you're sewing, and I'm going to stick it in the center. And actually for a volleyball there is a plug here, so I'm going to stick it on the plug and I'm going to go all the way around the ball. Okay, and what I'm actually doing right now is I'm measuring the circumference. Circumference is all the way around. Okay, it's right about 26 1/4. Okay, 26 1/4 if I go all the way around. And so I'm going to write that up here. My circumference is 26.25, and we were in inches there. Okay, so circumference, if you look at it, is pi times diameter. Or sometimes you see it as 2 pi r, which we know that 2 times the radius is the diameter. So in order for me to find the diameter or the radius, I need to divide by pi. So with our calculator, I got a big one today. With our calculator, let's do 26.25 divided by 3.14, and we would get approximately 8.35. So we're going to say 8.4, okay? 8.4, we're going to round it to the 10th. And that is actually not the circumference. I wrote that wrong there. What is that? That is the diameter, okay, because we divided this by pi. So we were looking for the diameter. Now, in our formula for a sphere, though, what do we need? Remember, our volume of a sphere is 4/3 pi times the radius cubed. So we need the radius. We have the diameter. What can we do here to get the radius? That's right, we can divide by 2. So our radius would equal 8.4 divided by 2. We know that 2 goes into 8 4 times, and 2 goes into 4 2 times, so 4.2. So here's what we're going to be using for our formula. And that is exactly what we have there on our screen, on our TV. So we're going to put 4.2 inches in. We've got to cube it, which means we have to multiply it 3 times, okay? And then we have to, so I'm going to do that on a calculator for you. So we need to do 4.2 times 4.2 times 4.2. And we should get 74.088, okay? And then inches cubed. Then we need to multiply that by pi and by 4. So if I multiply that by pi and 4, 4 times 3.14 is 12.56 times my radius cubed times 74.088. And I'm going to get 930.55, a whole other decimal expansion, but I'm going to round to the nearest hundredth. And then divide that by 3, because that's also part of our formula. 930.55 divided by 3 would give me the 310.18 cubic inches. So the volume of this sphere here is 310, we'll say about 310.2 cubic inches, okay? So maybe you had yours at home and you could measure out your circumference first, divide it by pi so that you get your diameter, divide it by 2 so that you get your radius, and then you can plug it into your formula. Remember, formula is like a recipe. You have to have the right ingredients. You can't substitute it. I couldn't put diameter in there when I needed the radius, so I have to go down and find my radius. Okay? Let's look at our next example. This example says, find the volume of a sphere and round to the nearest hundredth. We have a sphere here, and it's 8 centimeters. Okay? What is 8 centimeters? Is that the diameter, or is that the radius? That is the diameter, because it's all the way across. So in order to find the radius, what do we have to do? Split it in half, that's right. So if I split 8 in half, that's going to give me 4. If you look at our formula over here, we have 4 times pi times radius cubed, all divided by 3. So I need to do, and I'm going to plug in my ingredients now. What is my ingredient? It's radius, and I know that my radius is 4 centimeters. So I'm going to plug in 4 centimeters, and I have to cube it. What does cubing mean? To cube something, you are multiplying it by itself 3 times. So I have to do 4 times 4, which is 16, times another 4, which would give me my 64. Then I can replace 4 cubed with 64 centimeters cubed. Then I have to multiply my 4 times my pi, 12.56. And sometimes once my students started working these, they realized that 4 times pi, as long as I was asking them to use the 3.14 approximation, they just went ahead and put 12.56. That kept them from having to do another step. And that's completely fine. As long as you understand the formula, it's okay if you can go down to another step, as long as you can communicate that to your teacher. So you know that 4 times 3.14 is 12.56 times your radius cubed, which gave us 800. So let's make sure 64 times 12.56, 803.84, and our last step is to divide by 3. 267.95 centimeters cubed. Yep. So that is the volume of that sphere. Okay? What if we don't have a sphere? What if we have a hemisphere? What is a hemisphere? Like we said a while ago, a hemisphere is half of a sphere. If I take this top half off, these two are hemispheres. Okay? Maybe you've heard that in geography, or and you've been studying maps, you've talked about the hemispheres. Okay, so suppose you have half of a sphere, which we know is a hemisphere. We would use the same formula, but what will we have to do? If it's half of something, we would have to divide by 2. That's right. So if we do that, I'm going to show you this math here. Let's go to our board. Sometimes it just helps to explain it a little better as we go. So if I had the volume of a sphere, which I know is 4/3 pi times radius cubed, okay, and then I want the hemisphere, which means I'm going to have to divide by 1/2, or I'm sorry, divide by 2, not 1/2. I have to multiply by 1/2, divide by 2, then I could say, and on my screen there I have a 1/2 times 4/3 pi r cubed. Okay, stay with me here. So I pulled out my numbers here. I have 1/2 times 4/3. If I multiplied that, 1 times 4 and 2 times 3, this is what I would get for the volume of my hemisphere. Remember, we're talking about half of a sphere here. So I know that 4/3 can be reduced, though, because they're both even numbers. And when I have even numbers, I know that 2 goes into them. So I want to reduce this by 2. So 2 goes into 4, 2 times, 2 goes into 6, 3 times. And then I still have my pi r cubed here on top. So my volume of my hemisphere is similar to my sphere, but instead of having 4/3, I have 2/3. So 2/3 pi r cubed, okay? So we know that 2/3 is half of 4/3. So let's find the volume of this hemisphere. Let's find the one that's a piece of wood. So you would need to get some type of measuring tool. Maybe you have a measuring tape like this. Maybe you have a ruler. Maybe you have your dad, dad or mom's measuring tape if they do, okay? This one is approximately 2 inches, okay? This one is approximately 2 inches. So we want to, and that's the what? If we're talking about all the way across, then we're talking about the diameter or the radius? That's right. We're talking about the radius. Nope, diameter. Said it wrong. We were talking about all the way across, so we're talking about the diameter. Y'all have to keep me in check. If we're talking about halfway across, we're talking about the radius. So our diameter was 2 inches. So half of that would be our radius. Our radius would be half of 2. And what is half of 2? 1. That's right. So we're going to put in 1 here for our radius. And what is 1 cubed? That one's easy. 1 times 1 times 1 still remains 1, right? Times our pi times our 2/3. And we remember that pi is, if we're going to approximate it, 3.14. So 1 times 3.14 would just be 3.14 times 2 divided by 3. So let's do 3.14 times 2 and divide that by 3. Okay, 3.14 times 2, that gives us 6.28, and divide that by 3, gives us 2.093 repeating. So we're just going to say 2.09. That was the volume of that hemisphere. Okay. 2.9 inches cubed here for the volume of this. Interesting, right? A lot less. This is 2.09 for this half of one. Remember, this was 310 something. So we're going to wrap it up here. Let's see. Our lesson today, what we learned is we learned the volume of a sphere. We also learned the volume of a hemisphere by just taking half of it. Next week, we're going to be focused on essential concept 3, which is the last essential concept for this fourth quarter. It's about scatter plots, slope, and y-intercept. So we're moving out of volume. We probably won't have another water example, but we're still going to have fun. So make sure that you tune in next week to learn about scatter plots, slope, and y-intercept. Hope you're staying healthy and happy. Bye, guys.